Let's talk now about the SD-access management plane. The functions that belongs to the management plane are performed by this particular device that is known as the Cisco Catalyst Center. It was formerly known as DNA Center. Most of the DNA SD-access documentation talks about DNA Center, but it changed its name into Catalyst Center in 2023. This is actually the icon for DNA Center and Catalyst Center. This is a mandatory device. In order for you to claim that you have an SD access network, you will need an ICE server too in order to have your network become an SD access network. Because otherwise, if you only have an underlay and an overlay that you configured manually, you only have a campus fabric. So you must add to your campus fabric the Cisco Catalyst Center in order to say that you have an SD access network. And if you have an SD access network, your management plane is your Cisco Catalyst Center, formerly known as DNA Center. Now, what are the functions of this management plane? Orchestration, assurance, and visibility and management. We already know what management is. There is a set of functions that we need to perform in order to administer the network. So there are a lot of functions that we can include within management. So we are going to focus on these particular functions that are documented for the management plane: orchestration, assurance, and visibility. We will see that visibility is actually a part of assurance. So let's take a couple of minutes to talk about these terms: orchestration, assurance, and visibility. When managing our network, when doing network management, one of our chores will be provisioning new network features. So historically, we have been doing so manually using the command line interface with a lot of human intervention. But then we started doing automation with automation tools. We started running scripts that we will run through dozens or probably hundreds of network devices in order to reduce the burden of having to do that manually. But if you have done that, you know that you can face some issues when trying to run scripts across several devices. Some scripts may fail. So the next step in that evolution is orchestration. Orchestration tools can achieve complex automation tasks. So by doing so, we are going to run, still going to run automation scripts, but we are going to sense or evaluate or test the outcome of our scripts. And then we are going to take decisions on that particular outcomes, and then probably we will need to execute another task in order to restart our automation process in order to make sure that this complex task gets executed without errors. And if at some point we find a fatal error that we cannot fix, we're going to roll back all the changes that were applied. So orchestration gives me that ability to run complex automation tasks. That is what we are going to understand by automation. So you can think of all the chores that we have to do when managing a network, and orchestration is just a subset of all that set of activities. Now let's talk about assurance. Now, when doing management of our network, another set of activities is the day-to-day operation of our network. Several things can happen. You can either have issues. That means that your users are going to report that something is not working properly, and you have to troubleshoot that in order to find out a solution. Or you might want to just monitor how your network is working, and so you can take proactive action. So you might want to do both things when managing your network: solving and troubleshooting issues, and also proactively find the issues before they are found by the users. So in order to do that, you might want to gather as much information as you want in real time. You might want to gather relevant information. You might want to gather that information from several sources, for instance, end user devices, end user applications, network devices, and so on. So you're going to use telemetry protocols in order to do that. You might want to use NetFlow, you might want to use the syslog protocol, and so on. Then you might want to analyze this information, probably using an artificial intelligence tools, or feed it into a machine learning algorithm. And then you might want to find out the root cause of these issues, that you can find them proactively or reactively. So you might want to proactively monitor your network or troubleshoot your issues as your users are reporting them. So all this process is known as network assurance. And visibility is just a part of this process. So assurance is also a part of the intent-based networking. With intent-based networking, we are going to go into a loop process where we feed new instructions into the network. We run those instructions, and then we are going to analyze and figure out whether those instructions were successful or not. So that is also what we are going to understand by assurance. So in summary, for your SD-Access network, your management plane is run by the Cisco Catalyst Center, formerly known as DNA Center. It is a mandatory device in order for you to claim that you have an SD-Access network, and in order for your network to be considered to be a full-blown Cisco SD-Access network. And the activities that belong to the management plane are orchestration, assurance, visibility, that is part of assurance, and the management of your network as a whole. So remember that the Catalyst Center is a centralized device that it will provide you with an intent-based network management server. It is an integrated controller that offers you a single pane of glass view of your network. So that will be the summary for the management plane. I'm going to continue talking about more details about the Cisco Catalyst Center, how to deploy it, what features does it offer. So you might want to stay and watch if you are interested in that. So how do you deploy the Catalyst Center? You can go for a single node, so you can just install one server. You can install that server in your shared services block where all your servers are in your network nowadays, where your DNS servers are, where your DHCP servers are, where your wireless LAN controllers are, and so on. So where your IaaS servers are connected. So you might want to connect that in your shared services block or into, for instance, if you have an on-premise data center, you can also place your Catalyst Center there. Notice that in this case, if you only go for a single node deployment, you don't have high availability. So you can lose your Catalyst Center. It can become unavailable if this server hardware stop working. Then you will have your Catalyst Center as unavailable. And if your Catalyst Center becomes unavailable, your network will still be functional, but you will be losing some features. You will not be able to provision new services, so you will be losing orchestration, and you will be stopped gathering telemetry information from your devices. Remember that with an SD access network, we are continuously sending telemetry information from our network devices into the Catalyst Center. So if the Catalyst Center is unavailable, there is no way to store this information, so you will not have assurance. So if you want high availability, you will need to install a 3-node cluster. You will need at least 3 nodes in order to set up a Catalyst Center cluster. Notice that in order for this to work, you will need servers that manage the same amount of CPU cores. So for instance, if this server supports 44 cores, these other servers should support 44 cores, and these other servers should support 44 cores. They use or are seen as a single IP address. So there is a virtual IP address that will represent your whole Catalyst Center cluster. It will operate with no less than 2 nodes. So you can afford to have one node malfunctioning, and if you still have 2 remaining nodes, this cluster will still work. But if you have 2 nodes, some features will stop working and some other features will remain. For instance, assurance will still work, but some other functions will not. And you can go virtual if you want to deploy your Catalyst Center. You can even install this as a virtual machine on AWS. These are the requirements for this virtual machine. And these are the Cisco hardware options if you want to install it physically. These are the latency requirements for your network in order to have your SD access network working correctly. Your Catalyst Center cluster should be 100 milliseconds away from your border nodes, from your control plane nodes, from your wireless LAN controllers, and from your edge nodes. 100 milliseconds. The latency between nodes should be no more than 10 milliseconds, and the latency between the Catalyst Center and IaaS should be no more than 300 milliseconds. I have seen documentation that states that this number is actually 200 milliseconds. So the deployment is up to you. For instance, if you go for a 2-tier deployment, then you could install, for instance, your PSN ICE personas locally and the remaining of the ICE solution remotely, and your Catalyst Center remotely as well. And you can do so connecting those devices through a wide area network. And as long as this wide area network allows you to have 100 milliseconds of delay between your devices and your Catalyst Center, that will work. Or for instance, if you go for really small deployments, for instance, if you use Fabric in a box, which is a 1-tier deployment, you are doing so because you don't really have too much infrastructure in that particular place. So if you have a wide area connection that allows you to have 100 milliseconds from your Catalyst Center to your Fabric device, this can work. Now, the Catalyst Center as a device has a lot of features. It has automation features, assurance features, SD access features. For instance, it can be iOS image repository for your network. It can be your device that holds the inventory for your network. It can integrate with ThousandEyes. It can provide you with Cisco AI analytics. It is really good to make your life easier for Fabric networks with the SD access features. And you can configure that with some sort of wizards. So within the Catalyst Center and DNA Center, you have these workflows that are actually sets of wizards. With the DNA Center, they were organized in design workflows, policy workflows, provision workflows, assurance workflows, and platform workflows. So, for instance, if you wanted to configure everything related to IP, you will go for the design workflows, where you can configure global settings, DNS settings, DHCP settings, IP addressing settings, syslog, SNMP, NetFlow. So everything that you can think of IP, or for instance, for your repository, for your operating system updates, you can also do that in the design workflow. Everything related to virtual networks or scalable group tags or quality of service, you will perform that in the policy workflows. Everything related to orchestration, you could do so in the provision workflows. Everything related to assurance, for instance, proactive monitoring, issue management, dashboards, that will go into the assurance workflows. And everything related to third-party integrations using this DNA Center APIs, you will configure that in the platform's workflows. Now, the Catalyst Center workflows, as I could investigate, are a little bit different. They are grouped into design, provision, policy, and assurance. Now, this DNA Center, when it was designed, it was built on 2 subsystems. The first subsystem is the network control platform, and the second subsystem is the network data platform. Remember that before deploying or before actually making DNA Center, Cisco had another product that was known as Application Policy Infrastructure Controller Enterprise Module, or APIC EM. So this product evolved into what was known as DNA Center. And it is now one of the subsystems that are part of DNA Center. So DNA Center is made of the APIC EM still, and it will provide you with fabric automation, orchestration services, and physical network configuration. The other subsystem of the DNA Center is the Network Data Platform that is basically performing assurance. It will offers collection and analytics engines. That's it.